Welcome back. In this class, we are going to be discussing everything that has to do with division in number bases. Recall that in our previous class that we have discussed everything that has to do with multiplication in various number bases. The idea I want you to grab in this concept is that operation can be done in different number bases, and I've told you the reason why. Some bases exist that we are operating with them. Just further ahead, let's progress. In the world of number division, there is something that's very important. What you are doing is that you are using one number to reduce another number. Remember that I told you there are two major signs that we have in this word: amplifying sign and reductive sign. Addition and multiplication are amplifying sign because when two numbers combine with those signs, the value tends to be more than any of the number that combines. But in the world of division and multiplication, I said in the world of division and multiple subtraction, the opposite is the case. The answer will be less than either of the number that combine. So in the world of division, the first thing that you need to pay attention to is this particular syntax here. We have dividend, the number that we want to divide. We have divisor, the number that we want to use to divide it. We have quotient. This is the result of divisor dividing the dividend. So this is a simple equation that you can put to yourself or begin to understand. Now, anytime you may see it in your examination. But in the world of division here, there is something that is very crucial that we need to understand, because it is the fundamental basis of division in other bases. Let us see it. It is called fraction to binary. It is called fraction to binary. How do we mean? We want to see a fractional number, a number in such a way that A is divided by B, such that B is not equal to 0 and A is not equal to 0. Are you getting me? So B is not equal to 0, A is not equal to 0, and B is not equal to 1. If B is equal to 1, that is whole number. You know what I'm talking about. If B is equal to 1, let's say that A is 5 and B is 1. What is this? This is just 5. So B cannot be equal to 1 and B cannot be equal to 0. This will result in infinity. Are you getting me? So that is what the fraction is. A number above a number below. And we want to convert them to binary, that is number in base 2. I will also tell you if you want to convert it to base 3, base 4, base 5. It is the same thing that you need to do. Are you getting me? So if you have a fraction which is 1 over 16, you want to convert it to base 2. What do you need to do step by step? The first step is that you take the number, you multiply it by 2. Why are you multiplying by 2? Because they are converted to binary, which is base 2. If you are doing conversion to base 3, you multiply by 3. So you get an answer. Are you getting me? This one multiplied by 2, that's 16 over 2. 16 over 2 becomes 1 over 8. In this scenario, 1 by 8 is a what? Fractional number. There is no integer part. This is a fractional number, no integer part. Since there is no integer part, you write down a 0. Are you getting me? So then you go further. From where you stop, which is 1 over 8, you multiply it by 2 again. Then you get 1 over 4. There is no integer part, you get 0. You go further again. This is 1 over 2. You get 0. That's that. You go further again. But here, you see, you get a positive integer, a non-fractional number. Are you getting me? That is equal to what? That is equal to 1. So what is our answer? Our answer for this particular division will now be all these numbers combined together. Here, it will now be 0. Now preside it with 0. 0.0 0, 0, 1. I know the reason why I'm giving you this particular hint at the beginning of this course. This is because fractional conversion is one of the technical problems every student faces when it comes to number division in other bases. Are you getting me? That one has gone. Let us look at another one. We want to convert 1 over 12 to binary. If you want to convert 1 over 12 to binary, what do we need to do? I want you to watch closely what we are doing. So what do? We take the number, we multiply it by 2, it becomes 2 over 6, 2 over 12, then it becomes 1 over 6. There is no integer part. Everything is fractional. So we write 0. So the same thing, 1 over 6 multiplied by 2, it becomes 2 over 6, it becomes 1 over 3. That is 0. It has no fractional, it has no integer part. Everything is fractional. Then you go further. 2 over 3, that is 1 over 3 multiplied by 2, it becomes what? 2 over 3. 2 over 3. What do we do? Does it have an integer part? No. 2 over 3 is still a fractional number. Remember, the number above is still less than the number below. That is equal to what? And is 0. But look at this one here. Look at this one now. This one is 2 over 3 multiplied by 2. It becomes 4 over 2. This is improper fraction. This is where you need to pay a lot of attention. Whenever you have an improper fraction, there is an issue. And the issue is that you may have a whole number, which is integer number, in that fraction, so that you can pick it up and leave the fraction alone. That fraction must occur in such a way that, look at here, A must always less than what? Must always less than B. So that's the true fraction that we're looking at in this place. So in that scenario, we are having 1 plus 1 over 3. So this is the integer part, while this is the fractional part. Then we pick the integer part and write it, which is what? 1. So we go further. But as we go further, you can see that this begin to occur, reoccurring. We're going to stop at one particular point. That results in what? So notice the pattern actually repeats. That results in what? Is 0.000000001, 01, and 001. But that's how it will be going. So our answer will now become to what? Is 0. Remember that it is fraction. You are going to precise the number. All these numbers, we are going to precise them with 0 points. So it will now be what? 0. I mean, it's 0 there. I don't say 0 there. That's about 3. 0, yeah. Then 1, 0, 1. I stop at this point here. So for you, you can continue. Are you getting me? I'm not dragging away. You can continue. But what I want to show you, it is the basic principle that you can apply to convert a number that is fraction to a number in other bases, which is very, very important. Remember, we are dealing with division in other number bases. So now, this is another assignment I want to do. I want to now do proper division. Are you getting me? So this number, let us do the division in base 10 and let us see the procedure that it takes. And we are going to see how to do the division in base 2. Now, this is the number. This is the number. What do we have? 16. We want to use 16 to divide 225 by 16. A step-by-step procedure. How do we go? How do we go about this? It's very simple. Number one, you should know that the number division actually takes place digit by digit. You want to use 16 to divide 2 first. It's a process. You still have other digits. You want to use 16 to divide 22. That one goes 1. Only one time. I don't. Yeah, only one time. Of course, it's only one time. Then, for that, you multiply this by this, it makes 16. Are you getting me? Then what do? You subtract it. So 22 minus 16, that probably should be 6. So at this point in time, the first step has been done. You want to go to the next step. Are you getting me? The first step has been done, and you want to go to the next step. Remember that division occurs in step. And for you to get the proper way of doing this division, you must follow the step. Let us go to the second step. We want to use 16 to divide this. You can bring up down the 5 to make it 65. Are you getting me? You want to use 16 to divide 6. You know, it's not enough. We combine this one to 8. That make what? That make what? 65. So the question is this: how many 16 goes in? Sorry. Oh, I'm so sorry. If I'm not mistaken, this is 1, this is 16, okay, and that is what? 6, that is 5, yeah. So now, how many 16 goes to 65? That should probably be 4, if I'm not mistaken, because if I look at 5, that is 80, and if I look at 4, that is 64, yeah, 32, 32, that is 64. So I multiply 4 by 16. Don't multiply 40 by 16. No. We are dealing with this digit by digit. So this is going to be what? 64. So then you subtract again. Okay? You subtract again. So we are left with 1. So that is only digits that we are left with. 16 goes in this. Impossible. What do? We put decimal place, we put 0 here, then we add the 0 to this. Are you getting me? Well, at this point in time, we can say that we are left with what? 14, remainder 1. Then 1. Are you getting me? We can say that we have 14 and 1. That is that. But fraction and 1, we can still go further, and that's what we're trying to do. Are you getting me? That is what we are trying to do here. So, what happened next? Can 16 goes in 10? No. What do? We had another 0. But this 0, are we supposed to put it here? No, not. We can't put it there because we already have 1 0 after decimal place. Okay? So for that, we are left with what? How many 16 goes in 100? This should probably be 6. And that should probably be, let me say, okay, 96, because 16 times 10, that is equal to 160 divided by 2, that is 80 plus 16, that is 96, so 96. So we are left with what? With 4. We are left with 4. So if we are left with 4, we add another 0. Know that if we are adding 0 once we have this particular decimal point here, well, no matter the number of 0 you had here, please don't write it here, okay? So we have 16. How many 16 goes into that's the probability 2. Yeah, that is 2, man. That is 2. For that 2, what are we gonna do? We have 16 times 2, that is what? 32. 32. So we are left with what? 8. 8, right? So for that 8, we put this one here. Let's make it what? 80. How many 16 goes in 80? That is 5. Wow. So that's what? 80. So everything comes down to 0, 0. In some division, you will divide to infinity. In some division, you will divide to infinity. But luckily, this one does not end like that. But what are we saying? We have answer in this way, 40 remainder 1, or we have answer in this way. But the question is, if you want to convert this one to base 2, they ask you to do the division in base 2. The first thing is that you divide in base 10, then you convert every part to base 2. What are you going to do? You convert 14 to base 2. Are you getting it? For me to convert 14 to base 2, there are some jingles that we use because I'm working with base 2. I can say I can write 2 in 8 places, that is 8 bits. Okay? I can write 2 in 8 places, that is 8 bits. But I don't want to go to 8 places. places. How many bits I need? 1, 2, 3, 4, 5. Let me say 5 bits. If it can cover what I need. This is 0, this is 1, this is 2, this is 3, this is 4. Yes, it can cover it. So 2 raised to the power 1, any 3 raised to the power 0 is equal to what? 1. Any 3 raised to 2 is 2, this is 4, this is 8, this is 16. So I will now look for digits. Are you getting me? That give me a sum of 14. I want to convert 40 to base 2. I will look for digits that give me a sum of 14. 16 is above. Look at this one. 8 plus 4 plus 2. Yes, that's 14. So I have 1 here, I have 1 here, I have 1 here. But this one does not contribute, making it 0. So automatically, 14 in base 2 is 1110. I have done that. This is 14 in base 2. So we're still going to talk about these statements as we are going through this lecture further. So what is next? It remainder 1. So that remainder 1, no matter the number it remains, maybe 2, whatever. So then by the division, so now be 1 over 16. That is the remaining part, which is the fractional part of this division that will give you answer. But don't forget that we have done that division. Yes, I'm not going to say that again, just rewind the video, you're going to see the answer. And let's to that's to what? 0.0001. What are you going to do? You take this one and add this one to it. That is going to be your complete answer. Making 1110 plus, that's going to be 0.0001. So this should be the division of 16. This should be the division of 25 by 16. Are you getting me? In base 2. So this is the correct answer. What we want to emphasize in this place is that whenever you want to do division in your number basis, please, first off, do that in base 10. Then convert that base 10 to base 2. In some cases, your answer may result in some decimal, the fractional part. And look at the principle under the fractional part to do the conversion. If you are working with base 3, use 3 throughout. If you're working with base 4, use 4 throughout. This is everything that we are talking about number division. You can try all of this one by yourself at any of your convenient time. So this is all we have for you today. Thank you for listening. Please follow and subscribe to our YouTube channel. Just look for ABPF Consults online. You're going to see our video that we posted that explains to you further all the basic principles that you need to start with mathematics. And don't forget that in some of our concepts, we are using programming to visualize some part of this mathematics so that we can get in depth into what we are actually doing. Thank you for listening. ABP.